Hello, good evening. In this lecture, I will talk about cryptographical hash function. After that, I will start talking about cryptocurrency, cryptography algorithms, RSA, and elliptical curves. As I said before, cryptocurrencies all have two important bases. One is crowd. As I said before, proof of work. In fact, proof of work is an idea to implement the role of crowd, okay? And the second is cryptography. Cryptographical hash functions, cryptographical algorithms, and all prepare the security of the cryptocurrencies, okay? In last session, I have a talk about some cryptographical hash functions, especially MD2. As I said, MD2 is old and nobody uses it today because it was broken. And as a coursework, I asked you to have a search about a historical review on different cryptographical hash functions, old cryptographical hash functions, and discussing about how they are broken. The most famous cryptographical hash function which are used in current cryptocurrencies are SHA family or SHA. SHA is the abbreviation of secure hash algorithms. Before starting the session, let me show you how use these algorithms in Python. So we should use some libraries. As you can see, my Jupyter, please let me run the Jupyter. Okay. Okay. Now I can share my screen. Can you see this? Can you see this page? Okay. In the first block here, at first I have imported a library. The name of the library is hashlib. There are many cryptographical functions implemented in this library. I think when you download Anaconda, Python knows this library, but in the cases that you want to use a new library, simply you can use this command, pip install the name of the library. For example, not only in this session, but also in other sessions, I we use different kind of cryptographical algorithms. All okay, I will large all that libraries were implemented in the cryptography. Let me to I don't know how to resize the. Let me take a header, take a line number. Don't know how to enlarge the fonts. Sorry. Okay. So today I will introduce two libraries for working with different kind of hash cryptographical hash functions. The first one is hashlib. Okay, so you simply write import hashlib. Then you must have an object like m or whatever you want, whatever you like, equal hashlib, this library hashlib dot SHA 256. SHA 256 is the most famous cryptographical hash algorithms which is used in different cryptocurrencies like Bitcoin. Okay, so by this command, now we have an object m. M is an object of type SHA 256. Now this object has a method update. This method takes an input of type byte and generate its hash value. Okay, so I want hash my name. I want to hash my name. So this B converts the string Wahid to a byte sequence. Okay, as I said, update takes an input which its type is byte. To convert a string to byte, you should put a B in front of that string. Okay, so I put my name here. So this command converts my name to a hash value based on SHA 256. But I want to add another thing at that string, and I want to recalculate the hash value. To do so, again, I use the update, m.update. Now my family, which is an space in front of it, again, I convert the string type to byte. Maybe you say you could write something like this. Yeah, that's true. But many times now I want to calculate a string, and later I noticed that I should put something extra at the end of it. In those cases, you can simply use another update method and put the extra string at the as the parameter of update, something like this. Now update means update. update, the meaning is not important. Update, this method update, calculates the hash value. Hash functions, all the hash functions, takes one input and generates its hash value. And now, my first input is Wahid and the second is my family, and update calculates its hash value. And now I want to print the hash value. To do so, I use the print command. M is my object hash value. I convert this hash value to hexadecimal by this command, hex digest. So this command prints the hash value as a hexadecimal format. And then later on prints again that hash value in the byte format. So if I run this simple program, this is the hash value my name and family. In fact, the input was, okay. In the second part here, again, this part is exactly as the same of the above, but instead of using 2 times update, I just used one update, but I put all the data as one parameter. So this update takes just one parameter, my name, space, family, my family, okay? And again, I have printed the hash value as a hexadecimal format, as a binary format. If I run it, you can see the result is the same. Not surprising, because the data for these 2 simple program was the same. The input was the same. You can put anything, put your name, put every string you want, okay? You know, Hassan, it's just an example. I want to show you how to use this library, how to use these methods, how to calculate hash values. You can put everything you want. So I want to say that you can put all the string at once, or you can put in different steps. 1 time, 2 times, 3 times, 4 times, whatever you need. Okay, so you may have 10 update in a program. It's okay. So the first library, you don't have. Can you hear me? I think it's okay. The system says me that everything is okay. So check your system to be sure about problem. Okay, let's go. Again, for calculating the hash values, you can use another library, cryptography. This one was HashLib. Okay. There is no difference, both the same, but just the way of the representation is different. This is in hexadecimal format, Each hex digit, as you know, is 4 bits. 4 bits, okay? But here is exactly this data, but in the binary format, in the byte format. So it's byte, it's equivalent in hexadecimal format. Okay, both are the same. I want to show you how to convert a hexadecimal. This is a hexadecimal, and by this command bytes.fromHex, you are converting a hexadecimal format to a byte format. Okay, later we need this. My system is okay, my internet is okay. Unfortunately, I think there is some problem in your side, but everything is recording after the class. You can download the recordings, and I'm sure everything is okay. So using this command bytes from hex, we are converting a hexadecimal to its equivalent in byte format. As I said, in later sessions we need these commands. Okay, another library that I will use it more than hashlib is cryptography. For using cryptography, you must write a command like this: pip install cryptography, and you should have an internet connection. When you run this command, it's star here. In fact, tries to download and install, but in my system this library was installed before, so you see something like this: requirement already satisfied. Okay, so for the first use, you must at first, using this pip install cryptography, you must install this library. This library has different parts. For using hash functions, especially SHA-256, you should use cryptography hazmat primitives, and from cryptography hazmat primitives you must import hashes. Okay, just use this command, and now again I define an object M, but with this command hashes. This is hashes library, hashes, hash, which takes a parameter, and that's the name of the algorithm. In this case, I want to use SHA-256. Okay, so now I have an object. Again, using update command, in this case both libraries are similar. Using update command, I give my data for calculating the hash value, my name, my family. But here you can't use hex digest like this. You must finalize the hash value by this command. m.finalize finalizes the hash value. So digest now is the hash value. I can simply print the digest, or I can print the digest in the hex form by this digest.hex. Okay, if I run, both are the same. This is in the binary format, a byte format. As you can see, exactly the same as the before, even though the libraries are different, but since the algorithms are the same, both are SHA-256, so not surprising, the both outputs are the same. Okay, and this is the hash value, the hash of my name in the hexadecimal format. And why it's called 256? Because output is 256 bits. As I said, each digit is 4 bits. So 256 divided by 4 will be 64 digits. It's a 64 length strings. The length of this string is 64. Okay. Again, you can convert this hexadecimal to byte. I copy it, I put it here. If I, again, using bytes.from hex, you can convert a hexadecimal format to byte format. See? Again, the first and the third outputs are the same because both are byte format. Okay? These are the commands that later we will use them in later for calculating some cryptographical messages for encryption, decryption. Okay. You can use this without print, it's okay, nothing new. You can use different algorithms, not only SHA-256, you can use SHA-1. SHA-1, the output of the SHA-1 is smaller. I think it's 160 bits. 160 bits. Okay, so simply when you are using cryptography library, or even when you are using hash library, you can change the name of the algorithm. For example, SHA-1. Okay, simply. Obviously, the output will be changed because the algorithm is changed. Okay. Different SHA or SHA algorithms. SHA-1, you can use SHA-1. Output is 160 bits, or you can use SHA-224 or SHA-256, which are 224 bits or 256 bits, or you can use SHA-384 or SHA-512. This is the not only it's a part of the name of the algorithm, but also it's the size of the output in bits. Okay, it is the size of the outputs in bits. For example, SHA-384 generates hash values which has a length of 384 bits. Okay, so this is, you can put everything you want here. Every data, it's okay. So this is about cryptographical hash functions. Most of the cryptocurrencies are using this algorithm, SHA-256. Nobody could broke it till now. It's working, okay? If you have any question, please let me know. Otherwise, I will start encryption and decryption and RSA algorithm. So, till now, I talked about cryptographical hash functions. We saw MD2, different SHA algorithms, and their associated libraries and commands in Python. Please note, all are one-way functions. What is one-way function? Who knows? What is when I say this algorithm SHA-1 is a one-way function, what does it mean? Yes. Yes. You cannot use it by reverse. For example, using the output, for example, using this, you cannot guess the input. So it's one-way function. Using the output, you cannot find, or even you cannot guess what was the input. Okay? If you don't have any question, let me start the new topic. No question? Okay. Okay, now I want to talk about cryptography. What's my problem? My problem is, let me use the whiteboard. I'm here. Suppose that I'm Bob. Okay, here is Alice. Now I want to send the message to Alice, but encrypted. Nobody, like Eve, I don't want to know what's my message. Cryptographical hash functions like RSA, like SHA-1, SHA-256 don't work here. Why? For example, Bob cannot use SHA-1 to encrypt his message and sending them to Alice. Can you explain why? Here we need new algorithms. Algorithms like SHA-256 doesn't work here. Who knows? My problem is, please note, my problem is Bob wants send a message to Alice, and Bob wants Alice to read his message. But Bob wants nobody else, like Eve can read its message. So he wants to encrypt the message and send the encrypted message to Alice. When Alice receives the encrypted message, she must be able to decrypt the message and read the message. Okay, now my question is, why Bob cannot use an algorithm like SHA-256? What's the limitation? What's the problem with SHA-256 for encryption? For using as an encryption? SHA is a cryptographical hash function. It's not an encryption decryption algorithm. Why? What's the problem with SHA that we cannot use it as an encryption algorithm? What's the answer? The answer is very simple. No. Length is not the reason. Key? No. Yes, exactly. I think Nur Adnan got the point. As I said, hash functions are one-way functions. It means that, okay, Bob can simply hash his messages using SHA-256 and send the hash value to Alice. But how Alice can decode it? I said Bob wants to send the message to Alice, and Alice must be able to read the message. But how? Okay? So those algorithms like MD or SHA are hash functions one way. For encryption and decryption, we use another algorithms. Encryption decryptions, one way, hash functions are one way. Okay, since they are one way, we cannot use them for encryption and decryption. Bob can hash a message and sends the message to Alice, but Alice cannot decode the hash value. As I said, it's a one-way function. It's not possible to find the input from the output. So we need some new algorithms. One of the most famous algorithms is RSA algorithm. RSA is an encryption decryption algorithm. Okay. Another one is elliptical curve. In Bitcoin, elliptical curve encryption decryption algorithm is used. So in the current session and in the next sessions, I will talk about RSA and elliptical curve. One of you asked, what's the use of SHA-256 if it's one way? it's used beside encryption decryption algorithms. For example, for simple example, everybody in the cryptocurrency must have a public and a private key. Okay? Everybody must have a public and private key, and also everybody must have an address, valid address. All valid addresses must have the same structure. So in most of the cryptocurrencies, valid address is the hash value of the public address. Okay, so later when I start talking about blockchain, I will exactly explain what's the application of cryptographical hash functions, what's the application of encryption decryption algorithms in the blockchain. Okay, just for now let's understand how they work. What are they? Okay, in the first session I talk about public key and private key and symmetric and asymmetric encryption decryptions. Again, suppose Bob wants to send a message to Alice. Okay, and he doesn't want to know, for example, Eve, what's the message. So there are two different approaches. One, which is an old approach, is called symmetric. Symmetric, and the new approaches is asymmetric. Okay, in symmetric approaches, Bob locks the message with a key, and Alice unlock that message with the same key. For example, suppose that this is the message, hey, and suppose that key is 2, and Bob uses a very simple encryption algorithms. Bob converts each character to another character which has an ASCII code with the previous character plus 2. I don't know what's the ASCII code of H, but 2 characters after H is J. Okay, 2 characters after E is G, small g, and 2 characters after Y again is A. Consider alphabets are circular, okay? As a circle, consider the alphabets on the environment of a circle. Okay, so Alice receives JGA. Now Alice using exactly the same key decrypt by using 2 characters before. Bob used 2 characters after. Alice used 2 characters before. Finds the message. This is a very, very simple example of a symmetric encryption. In this approach, there is only one kind of key. Both sender and receiver has the same key. This kind of encryption is not so strong. So from at the end of year 79, new algorithms which are asymmetric are used. What's an asymmetric encryption or decryption algorithm? In asymmetric approaches, there are 2 kinds of keys. One is called public and the other is private. Okay, so in asymmetric encryption decryption approaches, we have 2 kinds of keys: public key, private key. So everybody in the network has 2 keys: public key, private key. Private key is private. Everyone knows only his own private key. Consider email. For example, my email address is v.rafia@gmail.com. Okay, you can consider this as my public key. Everybody knows my public key. So public keys are public. Everybody knows the public key of each other. But the password, my password plays the role of private key. Only me know what's my password. Okay? So in asymmetric cryptography, everybody has 2 keys: public key. All persons in the network knows the public key of each other. The second is the private key, which is really private. Only one person, the owner, knows the private key. Okay, how it works? Now, suppose that again, Bob wants to send a message to Alice. Now using asymmetric cryptographic algorithms. Bob has a message. Now Bob must encrypt the message with the Alice public key. Okay, Bob uses an encryption algorithm like RSA, encrypt his message with Alice's public key. As I said, everybody knows the public key of other persons. So Bob knows the Alice public key. Using Alice's public key, Bob encrypts his message and sends the encrypted message to Alice. Okay. Now Eve may have access to this encrypted message, but he cannot decrypt it. Only Alice can decrypt this message, with his private key. So Bob locked the message with the public key of Alice, and Alice unlock it by her private key. And this is the general idea of asymmetric cryptography. It doesn't matter what's your algorithm, RSA or elliptical curve. All the algorithm have the general form. Okay. For encryption, we use public key of receiver. For example, if I want to send a message to Zainab here, suppose that I want to send a message here, and I want only Zainab can decrypt my message. It's just an example, okay? I must use the public key of Zainab to encrypt my message. So Zainab can decrypt the message with her private key. Okay? And another thing. Now, again, this is Bob. Now, Bob has a message, or a not message, I say Bob has a document. Okay. Now, another important thing I forgot. Both public keys and private keys undoes each other. It means that if you encrypt a message by the public key, okay, if you encrypt, you can decrypt it with private key, and vice versa. If you encrypt a message with a private key, okay, you can decrypt it with the public one. Private key and public key is totally different for everyone. Hassan, as you ask, the answer is not only private key, but also public key is different. I have my public key, I have my private key, you have your public key, you have your private key. I have my email address, you have another one email address. Okay? So everyone has a different public key and private key. So public key and private key undoes each other. Okay? So consider this situation. Bob has a document. Now, Bob encrypt the document with his private key. Bob encrypt the document with his private key. And now send the encrypted document to the network. Okay. Now my question is, can I say now everybody can decrypt the message? True or false? Bob encrypt a document with his private key. Send it through the network.